for the session of PDA. Now we are going to design PDA to accept the language L equal to 0 power n into 1 power n such that n is greater than or equal to 1. For this we have to construct a PDA such that a string contains equal number of zeros and ones. For this will have the transition diagram. So when the transition diagram comes, we will have the start state as Q0. So here the PDA always has the input format, right? So the input format has, if when you are giving an input symbol as 0 and the top of the stack is Z0, after pushing this you will have this 0 as Z0. Similarly, when your input symbol is 0 and the top of the stack is 0 and now this stack contains 0 0, right? After that you will have this 1. So if I am giving 1 as an input symbol and my top of the stack is 0, and after this my stack will be, after pushing this 1, my stack will be epsilon, because whenever you see this 1, whenever the particular 1 is encounters, you have to delete an equivalent of 1 as a 0. For example, if my stack is like this, first I have to push Z0 as an start of the stack symbol. After that I have pushed 0, and after that I am pushing this. So this is known as equal number of zeros and ones. If I am having string kind like this kind of string is taking 0 0 1 1. So when I am pushing a 0 as an input string and Z0 as a start symbol, then my stack contains 0 as Z0. So 0 as Z0. After that, when again I put a 0 to a particular stack, input is 0 and my top of the stack is 0. After pushing it, my stack position will be 0 0. So this is something like this. Okay. So after that, after the 0 is pushing into the stack, if 1 comes in the sense, so 1 if it comes, so for each and every 0 we have to cancel the 1. For example, if the first 1 comes, we have to look at this stack and cancel for this equivalent of 1 for the particular 0. So for 1, if my input symbol is 1 over here and my top of the stack is 0, now I pop this stack. So that's why after the pop operation, my stack will be, it's an empty symbol over here. So that's why it is the thing. So if I'm getting again I'm having input symbol as 1 and the top of the symbol is, top of the stack is 0, and now if I'm after pushing on, after giving an input as 1, my top of the stack will be epsilon, right? So this is the way you have to write. So after that, so in for this 1 it is also cancelled. So for each and every equivalent of 1 and 0, it has to be cancelled. This is the way this PDAs working. At one point of time, all zeros and ones are cancelled. So now only the thing is Z0 is available over here, right? Only Z0 is available. For this, let me check it now. I am not having an input symbol, which is known as empty string, and after that my top of the stack is Z0, and after that, after this so here I'm reaching my final state. When I'm reaching this final state, I have cancelled everything, so Z0 is also get popped and you'll have this epsilon symbol. So it is reached in an empty it is reached in final state, which means it is an empty symbol. So after deletion of top of the stack Z0, we'll have this diagram like this, right? So for this we will have this symbol instantaneous description. So it's kind of is also said to be as ID format. So the ID format will be here. So it is also said to be as a transition function, right? This is also a transition function. So the transition function tells you here, so del of q0 comma 0 and z0. So whenever you are giving an input is 0 and the top of the stack is z0, so after getting this, so you will have this state on the same state, and you will have this 0 z0. So this is after pushing 0 onto the stack. This is the stack condition now. After that you will have q0 0 comma 0. It will have q0 comma 0 0. So the input symbol is, now the input symbol is 0 and the top of the stack is also 0. Now my stack is on the same state, which is known as 0 0, right? So the top of the stack is 0 0. After that you will have q0 and my input symbol is 1, and my input symbol is 1 now, and the top of the stack is 0, right? Whenever this kind of input is occurred, so it is going for q1, and it pops off this particular symbol on the stack, 0 on the stack, and gives it as epsilon, right? After that we will have again on q1, if you are seeing an input symbol 1 on the top of the stack is 0, you will get the same q1 state, and also you will have this epsilon, right? So if all this is actually equal to zeros, equal number of zeros and ones. So whenever you will have this scenario, so always it goes on popping, and it stays on the same state, which is known as q1. So once it is elapsed, all the inputs are elapsed at one particular point of time, so del function will be q1, and there is nothing, no input is given to this particular thing, and the top of this stack is z0, and you will have this, you will reach the final state, which is q2, and you also tell the state q0, which is known as empty. So this is the way you have to write the transition function for this. This is the transition diagram for this particular PDA, and this is a transition function. So now we have to check this input stream. So the input, let us check the 0 0 1 1. So because here equal number of zeros and ones, right? So we have to check the input stream. So for checking input stream, right, so we'll have this q0 w. So here w is equal to 0 0 1 1. So q0 w comma, we have this z0. Okay, so just equivalently we can say this q0 0 0 1 1, and we'll have z0. So now 0 on seeing q0 on 0, so q0 on 0. So what is the thing over here? So q0 so initial is z0, top of the stack is here, the top of the stack is here, this is known as top of the stack, and on seeing input is 0, you will get this, right? 0 1 1, and you have 0 z0, right? Now the 0 will be on the top of the stack. After that we'll have the and 0 is it or not on the downside of the top of the stack. Okay, after that we'll have q naught comma, when you give this 0 again, so the second input is also 0. Now you will get this right, 0 0 is it not. Okay, then so q naught now 1 if when I see this 1, right, when I see this 1, so 1 and 0, 1 and 0's get cancelled and I'm having this 0 is it not. After that we will have, so when you see this state, right, so q naught on 0, any number of 0, it has to be stay in the same state, which is q naught. On 1 it is going to be whenever q naught on 1, so after you have q naught on seeing seeing 1 as an input symbol, and my top of the stack is 0, so we'll have q1. So why? Because on the top of the stack is 0 and you'll have input symbol is 1, so it get cancelled. So according to this rule, right, so q naught on 1 and the top of the stack is 0, so you will get an epsilon over there. So we'll have this 1 and 0 get cancelled and we'll have this epsilon over here, so it retains the same state. So it is q1, right? So after that again the 1 is coming, so just see this, so again 1 is coming, read in the same state which is known as q1, and so 1 and 0 get cancelled and you're getting the epsilon over there, and after that we'll have z0. So once the state is reached, for example, if all my ones, zeros and ones has been all my ones has been read, so I'll go for this next state, which is a final state. So there is no input is given to this particular state, but the top of the stack is z0 and the output will be the epsilon. So I'll indicate the particular final state has been to indicate the particular final state has been reached, I'm checking here, so q1 epsilon z0 gets always to q2 epsilon. So hence the string given saying 0 0 1 1 has been accepted. So this is the way we will have to draw a PDA for the particular language. Thank you for the session. We'll see you in the next session.